Good afternoon.
Good afternoon, sir.
Shall we start or shall we wait?
Yes, let's wait for like 2 or 3 minutes.
Okay, okay,
I will minimize and send them reminder to join.
okay. Send them the reminder so that they can join. I will start after 2 3 minutes. Good afternoon. Good afternoon once again. Welcome to the session order and other activities from the different departments are performed. Now we are into unit 13, that is standardization, codification, and variety reduction. First of all, we will start with classification of materials. Classification is defined as the process of arranging things in groups or classes according to their resemblances and affinities and gives expression to the unity of attributes that may subsist among a diversity of individuals. When there are numerous items handled by an organization, their planning and coordination becomes extremely difficult, if not possible, if each of them is handled separately. The classification of material involves grouping of items according to some criteria. What is the purpose of classification? Following are the major objectives of classification: to devise procedures of planning and control for materials in a class, to devise purchase procedures, inspection methods, and storing and issuing procedures common to all materials in a class, to devise accounting and evaluation procedures common to all materials in a class. Now we will see how the major classification system works. It is on the basis of the nature of the material. Material can be raw. If we talk about raw material includes all those materials which are purchased from the original producer or other manufacturers and are used directly in producing the firm's product. For example, cotton and yarn are raw material for cotton textile mills, for they help in producing the final product, cloth. Secondly, we have machinery and equipments. All the machinery, both power and hand driven, such as presses, lathe machines, typewriters, electric motors, fans, and other machines used in the production and other departments, is classified as such. Tools also come under this category, and they are issued on loan basis to the various departments for a definite period gradually till their lifetime. Then comes consumable items. Those materials used in manufacturing process which cannot be used for the second time for the same purpose, since their utility for the purpose in question has ceased and the shape changed, are referred to as consumable items. Coal, coke, mineral oil, lubricants, cotton waste, paints, varnishes, oxygen, etc. come under this category. Then comes your chemicals. Substances obtained after undergoing certain processes in chemistry according to a formula devised for the purpose may be known as chemicals. They should be stored, preserved, and issued very cautiously after a careful scrutiny and proper analysis, since their use involves risk even to life. Items like carbide, acids, and salts, etc., are classified under this head. Then comes your inflammable items. Items highly susceptible to fire, such as petrol, kerosene, films, tubes, and paints, fall under this category. Due to their hazardous nature, they are generally stored as far as possible from the main building with complete firefighting arrangements in standby. Then comes your furniture. Movable contents of a house or a room, like chairs, tables, almirah, benches, and stools, etc., are furniture items. Their repairs, renewals, and replacements also require proper maintenance of records since they are issued temporarily on loan basis in the organization. Then comes your scrap material. On the expiry of the life of a particular item, the residue is called the scrap. Such materials as is left over as waste in the process of production is also known as scrap. Now, classification on the basis of usability of the material: serviceable, unserviceable, and obsolete items, finished and semi finished items, dead stock items, and unused items. Codification. This is a process of representing each item by a group of numbers and alphabets, indicating the group, the subgroup, the type, and the dimensions of the item. Many organizations in the private and the public sectors, railways, and DGS, indeed, have their own system of codification. The number of digits in a code may typically be somewhere between 8 and 13. Now, the role of these digits and some fundamental principles of codification can be understood by this example. Digit 1, 2, major group. That means raw material, spare parts, subcontracted items, hardware items, packing material, etc. 3, 4, subgroup is ferrous, non-ferrous, etc. metals. 5, 7, dimensionless characteristics, that is dimensional characteristics, that means length, width, diameter, etc. 8 is minor variations. 9, location of storage, where it is stored. 10 to 11, under user department of the organization. 13, product or product lines requiring the item, which where it will go, where it will be utilized. And 13 is any other information of inventory, accounting, and purchasing, etc. Now you can see how this coding is done. What is the objectives of coding? In order to identify the items correctly and logically for processing the transaction and to facilitate easy location in stores, a codification system should be evolved with the following objectives. The first one is accurate and logical identification. A separate code is allotted to each of the items available in the storehouse, indicating the size, quality, price, usability, special characteristics, and specifications. For example, a lead pencil of black color, HB quality, for writing purpose, and with a price range of 3 to 350 may have its code as 07 dot 39 dot 1236. Now the thing is that what these numbers mean. 07 indicates the group, that is stationary item. 3 indicates pencil. 9 indicates lead pencil. 1 indicates color, that is black. 2 indicates quality, HB. 3 is for writing purpose. And 6 is the range. Now this can be jumbled in any form. I'm just explaining it with that example how this number, what's number. Since if on this pencil, this code is written in an organization, so straight away the person who's going to use it will identify everything because that is a standard and is being followed in the organization. Prevention of duplication. All items are separately codified and are arranged in a logical order. Similar materials are grouped together, such as stationary items, and given a code 07. Once a code is allotted on a particular group, it is the decision on the organizational level, and in no case it is changed. Since each item has a different code number and various items are kept in different bins at different places, there can be no duplication in placing the orders, and no pilling up of the material will take place in the storehouse. Third one is standardization and reduction in varieties. For codification, grouping of identical items is done, and it enables the stores to examine the entire range of items. It facilitates the elimination of those varieties in place, of which other varieties of the like quality can be used. That is, this reduces the number of varieties to minimum. Efficient purchasing. The filing up of purchase requisition and preparation of purchase orders are simplified by the use of codes which easily indicates the material required. Buying instructions to the suppliers becomes easy and quick if there is a proper understanding of codification by the supplier. Efficient recording and accounting. Codes leads to effective stock control, efficient recording, and result yielding accounting. Chances of mistakes are minimized. Pricing and evaluation can also become more accurate and reliable. Easy locating, indexing, and inspection. The materials in the store have to be kept in an order. Computerization, maybe a number or alphabets, which can be used to design a code. However, a great deal of thought must go into the coding scheme if it is to satisfy a variety of users. The following considerations must be kept in mind when designing codes. First of all, brevity. The codification system should avoid long and unwindly description, which implies that the code should consist minimum possible number of digits. The size of the code would normally be dictated by the number and the range of the items and the number and types of alphabet on the data pertaining to the item. Number two, logical. The coding system should be logically fit for the needs of the user and the methods of data processing employed. Third one is flexibility. The code design should be flexible to accommodate changes without disturbing existing codes. We are familiar with the library coding system in which the codes do never get disturbed by the addition of new books. And all books to come in the future are easily accommodated by the existing code structure. Uniqueness. Each code must be a unique representation of the items it identifies. For example, an inventory item number or employee's identification code must identify one and only one inventory item or employee. Easy understandability. The code structure must be easily understood by various users. Then comes your codification system. There are several systems possible for codification of materials, depending on the choice of coding symbol, alphabets, numbers, or a combination of alphabets and numbers. That is alphanumeric. Two popular fundamental systems are BRISC and Kodak. Now we will see what this BRISC system is. The brick system is based on numbers from 0 to 9 and consists of blocks, typically 3, separated by decimal points. The blocks are assigned specific classification of the material. The first leftmost block represents the major classification, that is The following example for stationary item explains the bricks system. The major stationery is classified into four groups based on the nature of each item, and each group in turn is divided into further subgroups. The system proceeds in the following steps. The material to be coded are grouped together so as to form a major group. The grouping should be accurate and homogeneous and should not overlap. It is based on the classification system described in the previous section. After the classification of preliminary grouping, the materials are further divided and subdivided as we have seen earlier. The basis of these division and subdivision describes the material in as great detail as possible and simultaneously making them relevant to the user. The codes are assigned in three blocks separated by decimal points. The total number of digits can be any as per the convenience, but in general it should be 7 in number. Now we can see this is basically a material sheet of an organization. See how the codes are done. It should be in four blocks. First one is the main, second one is schedule 1, and third one is schedule 2. If we talk about it is a stationary item, that is 63. If it is pencil, it will be 01, and it is of black color, it will be 41. So straight away when we see a number 63.01.41, so we can say that this is a stationary item, pencil, black in color. Suppose we take up an example of 630417. That is 63 is a stationary item, 04 is a ink pen, and 17 is used for duplicating. These are the standards. Second one is Kodak system. Kodak system has been developed by Eastman Kodak Company of New York, USA, and is supposed to be a very comprehensive system. It consists of 10 digits of numerical code. The basis of the major or first level grouping is source of supply. All materials are divided into 100 basic classifications based on purchase and procurement consideration. For instance, a bolt is listed as hardware item. If this is listed in hardware catalog and available with hardware supplier, if this bolt, however, is available only as a part of machine, it will be available under maintenance. Each class is divided into 10 subclasses. For example, if class 20 represents cutting tool, then 200 represents drills, reamers, and counterbars, etc. Color coding. Sometimes color codes are used to identify the item. Common instances are red, blue, green in an electric cable. Everyone has seen it. Red, green in electric switches, and so on. Some organizations use the codes locally, such as to identify steam, water, and other pipes, while there exists some national or international color coding systems. The limited number of colors available narrows the scope. This is, however, quite an effective system, providing easy identification. What are the drawbacks of codification? Sometimes the code becomes so complicated that it is difficult to understand. Coding of some characteristics like tolerance level of finish and degree of automation is quite problematic. Wrong identification may be possible if codes are not clear. Color codification may create confusion among materials. It may be confusing to the vendors to handle two or more organizations simultaneously to supply them the same article, having different codes by them as per their own convenience and requirement. Everything, how much standardized you may like to make, but everything has some drawbacks and some limitations. Nothing is perfect. We try to make things perfect, but is always there. Standardization and variety reduction. Standardization is the process for formulating and applying rules for an orderly approach to a specific activity for the benefit and with the cooperation of all concerned in a particular for the promotion of optimum overall economy, taking due account of functional conditions and safety requirements. This is standardization. A standard is defined as a model or general agreement or of a rule established by authorities, consensus, or customs created and used by various levels of interest. The standard could cover a variety of industries such as engineering, textile, chemical, pharmaceutical, agricultural, as also education. The topic covered under standards can include purchase contracts, forms, sampling, testing, and safety measures, etc. Standardization enables the materials managers to achieve overall economy and can supply, and this will imply better availability, better price, and better delivery. Standardization also implies routinizing purchase efforts, less stock, and hence less obsolete items. It also means less inspection efforts. As a matter of fact, many organizations do not check routine items bearing ICE marks in a very detailed manner, but resort to inspection of only a small fraction of items. The process of standardization logically leads to simplification or variety reduction. This implies reducing unnecessary varieties and standardizing to the most economical size, grades, shapes, colors, types of parts, and so on. In large organizations handling lakhs of items, it is quite possible that there are several items having very little variation in quality, dimensions, or functional effectiveness. What are the benefits of standardization? The important benefits are standardization helps reduce inventory item, increasing efficiency. It helps in evolving better means of communication, ensures interchangeability, and thereby convenience to use various products. Standards also aim in to protect health. Standards on infant milk, food, and infant formula ensures that there are adequate nutrients for optimal growth of the child. And in standard for food products, limits are set for elements injurious to health. Hallmarking on gold and silver ornaments effectively arrests the fraud and forgery on making and sales of precious jewelry. By using national standards, it is easier to locate sources of supplies, and in the case of machine parts, the replacement can be obtained easily. It could also be used in advertising for the products as well as of the spare parts. Effective steps have to be taken in a number of organizations in India for cost reduction in the number of stores item. The item of standardization should be to have uniform standards for similar items, and the standards evolved should have cognize of the indigenous availability of material to the maximum extent possible. With these broad national objectives in view, Bureau of Indian Standards (BSI) has developed and promoted more than 20,000 standards covering raw materials, components, and finished products by the end of the year 2021. And what are the disadvantages of standardization? Change of public taste or liking, fashion, and trend may seriously affect a company producing only standardized product range. The process of product development is hampered due to monotony and non-flexibility of product range. Thirdly, it reduces the variety of products to be offered to the customers, and the workers feel bored and fed up doing the same routine job again and again if too much standardization is enforced. Now we move to Unit 14, that is related to waste management. Waste management is basically the end of the cycle. Now, what to do with those things which, when they were good, they were used.
Wani sama? Wani abinci? Hmm? Kuma Juhel zai kai babu yan boys ɗin su ma kai. Juhel su ma babu yan boys ɗin su a kai.
Please mute yourself.
Fara kayan nan na ga wacin. Salu surgical bullet ya kana.
Now we are talking about waste management. As I was saying, this is the end of the cycle. But still, this is not the end of the cycle. The thing which was new was used for a period of time till it provided services to you. And when its life got over, what to do with that? That is to be understood and studied in waste management. For you, it is a waste or a scrap. Now, what to do with that scrap? That cannot be thrown up. It may cause environmental disbalances. We will study over here what we will do. Under waste management, it is a multidisciplinary activity involving engineering principles, economic, urban, and regional planning, management techniques, and social science to minimize the overall wastivity of the system under consideration. A systematic approach to waste management encompassing the waste of all kinds of resources at all stages should be adopted. However, as the material constitutes a major fraction of the total product cost, material wastage are of critical importance. Complementary of waste management and resource management. A system basically takes some input, process it, and gives the desired output. Some input is essential in whatever form for the functioning of a system. An ideal system is conceptualized to transform the total input into useful or desirable output. In view of the known physical laws of nature, the existence of an ideal system is not possible. That is, 100% utilization of resources is not practically possible for any system. To paraphrase, some waste is inevitable in the functioning of any system. Now you see how this input processing output system works. Input was given, it was processed, and the output was taken. Now, when the input is being made, some waste is generated. When processing is done, again some waste is generated. The output is obtained, again a waste is generated. Now the thing is that if that much of waste is generated, what to do with it? Better it, two things can happen: recycle it or dispose it out. Because you have to decide, it's the decision of the organization that how to dispose it. Once you have decided to dispose it, now it is the responsibility of the organization how to dispose it. The main objective of waste management is to minimize the waste, thus aiming at the ideal system, while the resource management aims to maximize the utilization of the resources. The goal of waste and resource management is same, that is optimum utilization of the available resources for higher efficiency and growth of the system. But the approaches are different. Now we see how complementary relationship of waste management and resource management. You see, resources are there. This is nothing that much technical. It's very well, it can be easily understood. There are resources, they are utilized. When they are utilized, they create waste. And resources are wasted also. Now, resource management is to maximize utilization. Management works on it, and maximum management responsibility is to minimize the waste. Now, to maximize utilization and to minimize waste, optimal resource utilization has to be approached. Taxonomy of waste, the science or technique of classification of waste. Lack of coordinated work in the field of waste management has given rise to the multiplicity of terms and definition of various types of wastes. The need for standardization of the nomenclature has been felt for systematic research and effective implementation of waste management programs. Wastes can be classified in variety of ways, depending upon the purpose for which classification is done. On the basis of resource wasted, various types of resources are wasted at various stages in the system, and on the basis of the source of origin. The source of origin may serve as an efficient and practical way of classifying waste. For example, agriculture, industrial, municipal, residential or domestic, commercial, construction and demolition, etc. These are the categories where wastes are generated. And on the basis of property, this classification is meant for material waste only, depending upon the property that affects the environment. Maybe of two types, hazardous and non hazardous. Then comes on the basis of recoverable. As per the characteristics of resources of the waste, it may be classified as recoverable, the waste that can be converted into some useful resource. That is, for example, material waste, energy waste, reused in another process, etc. Non recoverable. This includes the resources that are lost with the time and cannot be regained afterwards. That is, manpower, energy, capacity, and services, etc. This is basically the identification of resources based classification of waste. If we talk in terms of energy, it is physical, human, or solar. Material, it can be solid, liquid, or gas. If we talk about capital, it is waste of capacity, equipment or machine hour, and inventory. Data and information, because we are much more worried, we're talking about data and information, so that it will be undesired data, wrong information, information unutilized. So everywhere we see capacity. What is the definition of wastivity? Gross and net wastivity. Most of the productivity measures at present compare the total output to individual inputs, that is, material, energy, manpower, and capital, etc. While they usually fail to directly compare the fraction of particular input that goes into output. Further, it is difficult to measure the output of various individual inputs invested in various finished products, whereas it is comparatively easier to assess the waste of various inputs. Hence, a new concept of wastivity. That is what we have read earlier, that was efficiency. Now we are talking about wastivity. That can serve as an adequate measure of performance of any system, and it is rather easy to measure. Wastivity of any system is defined as the ratio of the waste to the input, that is W by T. Depending upon the level of waste under consideration, the wastivity may be categorized as gross wastivity and net wastivity. The gross wastivity is defined as the ratio of total waste generated by a particular system to the total input to that system. However, a fraction of total waste generated is intermediate to the system and gets recycled. Thus, the net weight to be disposed of or reused in any other system is less than the gross weight generated. That means your net waste will be total waste minus generated waste recycled within the system. Now, the ratio of the net waste to be disposed of to the total input to the system is termed as net wastivity. The net wastivity will be dependent on the extent of recycling. It is a ratio of net waste generated to the total input. Now, how to compare wastivity and productivity? Waste can be indirectly served as a good measure of productivity. And productivity of any system has been defined as the ratio of desired output to input. Most of the productivity measures at present compare the total output to the individual input, that is, labor, material, energy, and capital, etc., while they usually fail to directly compare the fraction of particular input that goes into output. The wastivity, on the other hand, for each type of input, thus indirectly assess the productivity for each type of input. Both productivity and wastivity are complementary to each other, which bears in it the inherent cause and effect phenomena. If the cause, that is wastivity, is checked, the effect, that is the productivity, will automatically be improved. What are the functional classification of waste management? For an effective and orderly management of wastes, the fundamental aspect and relationship must be identified and clearly understood. The efficient waste management comprises of the quick identification of the waste generated or caused, economic reduction, efficient collection and handling, optimum reuse and recycling, and effective disposal of waste, leaving no environmental problem. Waste management can be functionally classified into five basic elements, that is, generation, reduction, collection, recycling, and the last one is disposal. Waste management should be viewed in totality, considering the interrelationship of basic functions, element, and system. One of the objective of waste management is to optimize these basic function systems to provide the most efficient and economic solution, commensurate with the constraints imposed. By considering each element separately, it is possible to identify the fundamental aspects and relationship involved in each element. Secondly, it develops, wherever possible, quantifiable relationship for the purpose of making engineering comparisons, analysis, and evaluation. What is a systematic approach to waste management? A systematic approach to minimize the total system waste, minimizing the waste at individual stages, is conjunction with other stages has become proposed. Now this is basically a big gamut of stages. How to recognize weight, identify the stage in which it is caused. But it can be different stages. It can start from stage one till stage n. Then does the reduction efforts of stage one effect increase in waste of some other stages? If no, establish control to prevent reoccurrence. And if yes, identify the stage and waste cost. Now, in which stage it was. Now, again, identification of the stage has been done, and we obtain a break even between various stages to get total minimum waste. This is basically monitoring and awareness. It provides a scientific and systematic method for waste reduction at individual stages and finally for the whole system. The procedure for approaching the whole to part and then from part to whole is proposed. The basic steps are: recognize the waste for whole system, identify the state at which the waste is caused or generated, visualize the whole system into fractions caused as various stages, apply the systematic waste reduction procedure at each stage separately, and try to obtain a break even of wastes at the related stages so as to minimize the total aggregate waste of all the stages, and establish controls to prevent reoccurrence of the cause of waste generation. The waste management system for individual organizations, sectors, as well as the whole economy should be designed to fulfill the goal of zero waste. Zero waste should not be misinterpreted as no waste is generated. Such an interpretation will be neither feasible nor justified. As some waste is inevitable with the function of any system, 100% efficient system is only hypothetical. The main theme of the philosophy of zero waste is to first of all try to minimize the waste generated as far as it can be technologically and economically feasible, and whatsoever little waste is generated should be should put to some effective use. Waste control system. Collection has got a significant effect on subsequent functional elements such as public health, aesthetics, housekeeping, and public attitudes concerning the operation of the system, as collection and transportation constitute a major cost in waste treatment, up to 80%. Streamlining of collection of techniques can greatly improve the efficiency and effect a significant saving in overall cost of waste management. How what is recycling of waste? National Committee on Science and Technology has identified number of recycling projects. The terms recycling, reuse, reclamation, and recovery have different interpretations, though these terms are generally used as synonyms. Recycling generally refers to the use of undesirable output or waste as input to some process or system. That is, recycling of foundry scrap. Then comes reuse. Reuse may be termed as the use of waste generated from one process or system as input to some other process system as a raw material. That is for the generation of power or byproducts. The conversion of damaged, rejected, and undesirable outputs into a desirable output by repair or processing is termed as reclamation. The term recovery is utilized to donate the gain of resources from the waste. The recent development of recycling of waste in our country have been noted. New jersey for the players of cricket and football is being prepared from used water bottles. Number two, plastic sieves made from the damaged and rejected polythene bags for separating coarse grain from the fine ones are under circulation for domestic use. Third one, environmental friendly writing paper are being prepared from recycled plastic bags, chappals, and containers. Great progress has been made to make buildings from fly ash bricks and highways with plastic waste and rubber combined. You can search for it. These are being practically performed. Waste disposal system. Now, we will be talking about the last stage where waste cannot be regenerated, reused. This element links the waste management system with environmental and the other system and has got a significant impact on the same. The adoption of poor disposal practices have resulted in severe environmental pollution in different parts of the world, particularly in a big industrial centers, and have posed serious health to, threat to human beings. Some of the developed countries have taken the problem on war footing and have started developing and adopting latest technology in this regard. In India, the awareness has grown recently, and the design of effective waste disposal system has become a challenging problem area. From disposal viewpoint, waste may be classified into solvable waste and non-solvable waste. A guideline for disposal of solvable waste. The solvable waste, that is scrap, surplus or obsolete stores and equipments, unserviceable appliances and machinery, abandoned vehicles, etc., is generated in almost all sort of manufacturing and service providing establishment. No particular attention has been made in most of the organization for the disposal of solvable waste. The most common practice is to dispose the scrap surplus through auction. No systematic procedure have been developed in this regard. Another mode of disposal adopted is to salvage the scrap through a specialized agency. Directorate General of Supply and Disposals (DGS&D) is playing a vital role in public disposal. It disposes the stores worth several crores of rupees every year for various government departments. I'm talking about in India. A special surplus disposal committee was set up for analyzing the large quantities of accumulated surplus. The committee, in consultation with Metal Scrap Trade Corporation and Minerals and Metals Trade Corporation Limited (MMTC), has suggested some procedures for the manner of disposal and the market analysis of the huge ferrous and non-ferrous scrap in the country. Some broad guidelines have been suggested to aid the design of system and procedures for disposal in individual cases. First of all feasibility of recycling should be analyzed to dispose the scrap. Try to use the scrap for producing byproducts. Third one is try to transfer the surplus from one department to another or to other plant in case of multi-plant organization. So that's a waste for someone can be an input for the other. Analyze the feasibility to sell the scrap as raw material to other plants and to sell the scrap surplus to external export agencies dealing with it. Second part is processing and disposal technique for non-solvable waste. Processing techniques are used in solid waste management system to improve the efficiency of operations. That is, to reduce the storage requirement, facilitate disposal to recover resources, conversion products and energy, and to minimize harmful environmental effects. Various alternative processing disposal techniques have been briefly discussed here. First one is mechanical processing. The mechanical processing of the waste is done to reduce its volume and size for easy handling and disposal and to recover valuable materials from separation. Thermal processing of waste results in volume reduction, generation of energy, and byproducts. The overall heat content of solid waste, including moisture and ash, etc., is approximately 10.5 million BTU per ton, most nearly comparable to that of low rank lignites. Then comes bioprocessing. For agriculture based economy like India, bioprocessing is become an important research field to produce fertilizers, alternative fuels, and feeds, etc. Some bioprocessing methods are composting, fermentation, and hydrolysis. Then comes composting. Composting of solid waste may be defined as biochemical stabilization of those organic materials to humans like substances through scientifically producing and controlling an optimum environment for the process. Third one is design effective waste disposal system. The design of effective waste disposable system in an important aspect of waste management. The system should be designed to promote the maximum possible recycling, reuse of wastes, and for minimum environmental hazards. First of all, the technical, economic, and social feasibilities of recycling, reuse should be analyzed and attempts should be made to recycle the waste as it is without any processing. If the residue left after optimum recycle reuse is disposed as it is, then the mode of disposal should be selected. Otherwise, various processing techniques should be evaluated by considering various social and economic factors. Both the source as well as centralized processing methods should be selected properly. Finally, plans should be prepared for ultimate disposal. Various factors that should be considered in design of waste disposal systems are public attitudes, regional and national policies, the economic consideration, land availability, equipment requirements, groundwater protection, environmental control, fire prevention, litter control, operations plan, employer facilities, equipment maintenance. The list is an operational records. Now we move to a model that is input output waste model, IOW, to provide a closer representation of real life system. It is proposed to remodel them in the framework of IOW model. The proposed model will be able to define the resource balance more realistically by incorporating the reduction, recycling, abatement, disposal, and related functions of waste management. The IOW physical system defines the resource constraint for every viable system as the balancing of inputs to the sum of outputs and waste. That is, input is equal to output plus waste. They're including that thing. What is the basic framework? Basic framework of our IOW model defines IOW flow matrix, IOW coefficient matrix, and consistency equation. IOW flow matrix consists of a set of conventional intermediate demands or resource flow matrix extended to include waste management sectors, final demand matrix, plus added waste flow matrix and aggregated. We will see over here. What is this IOW matrices? Intermediate demand or resource flow matrix, final demand matrix, and total output. Initially, it is input of resources, total waste, total final demand. In that, we include waste flow matrix and and the last, the total waste is generated. That means your total input is in the form of resource input plus recycled waste. This is IOW flow matrix. IOW coefficient matrix consists of technological coefficients matrix, final demand coefficient matrix, and waste management coefficient matrix, partitioned for intermediate and preliminary inputs and intermediate and final wastes. For consuming sectors, technological coefficient matrix, intermediate input coefficient, primary input coefficients, and waste management coefficients matrix intermediate waste coefficients all are added up. When all these are added up, then the final waste coefficient comes. The problem of waste management should be visualized in a broader perspective and an organized system approach to waste management should be adopted. It is unfortunate that despite of crucially of waste management in socio-economic resource structure, it is ecological and environmental compatibility. It has been ignored most of the time. There is a need to standardize the taxonomy of the waste and to critically analyze the functional elements of waste management. Waste management is a dynamically emerging field with vast scope, though awareness in this field is growing slowly, and if proper attention is paid, it may rapidly gain momentum. To accelerate the efforts to which universal sanitation coverage and to put the focus on cleanliness, here in Government of India has launched Swachh Abhiyan, Bharat Abhiyan on the 2nd of October, that is 2014, on the birthday of Mahatma Gandhi to effectively handle the waste management. Indian government is working and thinking, and so everyone should think of doing that. Now I will take some problem. I don't know whether you are aware of it or not. We have, we will be designing I will show you something. Have you seen this kind of problem in your course? I don't know. I'm not aware of it. Whether you have seen that this is basically a practical example.
Yes, I've
How
seen it.
you have seen it? That's good. That means there is no need. I was thinking of that you might have done it or you have not done it, and you are very well aware of how to solve CPM and PUD problem.
No.
Have you seen this problem? First of all, I will be taking two problems. Have you seen this problem, Madam
Now,
Grace?
yes.
Yes, sir.
Yes. Now yeah, I can see that one.
No, no. Are you aware of how to solve this problem?
No experience.
That is what I'm asking you. This is a practical problem, and it
Well,
is
the
in your
answer is
course
no,
also.
sir. No.
No, that means I should tell you how to solve this problem. Now, see, we have to design an assembly line for a cycle time of 10 minutes for the following 12 elements, and we have to use Kilbridge-Wester method. The problem is given to you. What is the problem? This is the problem what is given to you. Not, that's it. And you have to first of all draw this. If you have seen it, if you have gone through CPM and PULT, then you might be knowing these the elements and intermediate procedures how they are marked in it. If you are aware of, it's very good, and if you are not, then please listen to me what I'm telling you. It will be useful in CPM PULT also. Now see, the element is 1 2 till 12. There are 12 elements. They are being processed at different levels, and if they are processed, there will be some processing time. First of all, now you see that for element 1, this is 1, and if we talk about element 2 will be either here or here somewhere, but initially we write 2 at the top here. What is the immediate procedure? That is 1. That means 1 will be connected to 2. Now we move to 3. 3 is connected to 2. So this will be here. 3 is connected to this. Now when we move to 4, we find that immediate predecessor is 1. Straight away come down, mark 4 over here, join it. Now this has been complete 5. 5 is where? At 4. 5 is where? At 4. So 4 was here, join 5. Right? Connected. Now this part has been solved. As soon as we reach to 6, we see that it is connected to 3 and 5. Where is 3 and 5 in your diagram? 3 and 5 are here. Straight away draw 6 and join them. Now this part till here it has been completed. When we talk about seventh element the immediate predecessor is 6. Here you have 6. Write 7 over there. For 8, move further, block 8. Now when we talk about 9, the immediate is 6. Where is 6? 6 is here. Write 9 over here. Predecessor is 6. Where is 10? 6 is here. Draw 10. Now this part has been completed. Now when you move to 12, no, there is 11 also. 11 to 10. 11 to 10. 10 is here. Write 11. Finish. Close it. Now, when we come to 12, 8, 9, and 11 are the immediate predecessors. Where are 8? 8 is here, join it. Where is 9? 9 is here, join. And where is 11? 11 is here, join. Now, this is the diagram. That means we have utilized these two rows. What about this? This has to be utilized for the duration. For 1, it is 5. Draw these dotted lines and write 5. 2 and 3. Second stage, 3. Third stage, 4. Fourth stage, 3. 5, 6. These are the numbers written at the top. 6, 5, 5. 7, 2, 2. 8, 6. Where is 8? 8 is here, 6. 9, 1, 9, 1. 10, 4, 10, 4. 11, 4, 11, 4. And 12 is 7. Last is 7. Now, technically, what you can see, don't right now we have drawn the path. Now we have to club the elements. First of all, we will club like this, second like this, third like this, fourth like this, fifth like this, sixth and seventh. Now, this diagram has been drawn. Now, what is the next step? This is the same diagram what you have drawn over there. This is grouping is done preliminarily as what we have it. Now we have to see the processing time. After this, this is drawn. Now see to it how it is drawn. Element 1, time is 5, that was given to you. Station sum is 5. Your optimum time in the problem was 10 minutes. Cycle time was 10 minutes. So that is why I'm subtracting it. Okay, initially that has to be started. The complete cycle time was 10. 5 has been utilized over here. The 5 is remaining. Now in the second, what is happening? 3 plus 3, 6. 6 is the session time. And you have to take the maximum of the element number. Now station 3 has 6 plus 4, 10. Your station, your time was 10. 10 minus 10 is 0. This is 4. 10 minus 6 is 4. At 4, it is 5. 10 minus 5 is 5. At this is 2 plus 1 plus 4. 7. 7, that means 10 minus 7 is 3. Here it is 10. 10 minus 10 is 0. And at the last, it is 7. So 10 minus 7 is 3. Add these up. Total, what is the total time? Add these numbers. What you are getting?
Is it 15?
The total time is 50.
Oh, plus 5, 20.
Now, how to determine the line efficiency? That is sum of stations time of various work elements, that was 50, divided by total number of workstations, that was 7, and the cycle time was 10 into 100. This comes out to be 71.43. I'm talking about the line efficiency. How much is the balance? 100 minus 70.47. That means you have balance delay of 28.57%. That is quite high. It has to be. reduced. Now, what is the smoothness index? These numbers 5, 6, 10, 5, 4, 0, 5, 3, 0, 3 has to be square and added up. Square and added up. This again comes out to be under root 84, which is equivalent to 9.17. This is again high. That means we have to change the line system. Your line efficiency, your balance delay is quite high, that is 28.57%, and smoothness index is 9.17. It is again too high. I'm just reshuffling this. See to it. How many workstations are there? Work options are there. Now, one, two, three, four, five, six. In the earlier problem, we were having seven. Now we are having six. One and two has been clubbed. Three and five has been clubbed, and three and six has been clubbed. 7, 9, 10 in single. 6 and 11 has clubbed, and the last one is sixth one, that is 12th. Now, what to do? Get back to the same thing. The process time is 10, 15 minutes. Now, we have to find the ideal time. You have to subtract 9 from 10, you will get 1. And for station 3, this is 6 plus 3. 9, subtract 9 from 10, again you are going to get 1. Subtract 7, you will get 0. And for 6, you will get 3. Going back to the same calculation, 15 minutes. There is no improvement in it. That means the balance delay has been reduced. Now it is 16.67%. And smoothness index from 8 has been reduced to 4.89. From the above result, we see that there is an improvement in the line efficiency from 71.43 to 83.33. That means an improvement of almost 11%, 12%. And also, the values of balance delay and smoothness index has gone down considerably, which is a positive sign for balancing. Now I will show you a problem related to CPM part. Are you aware of the difference between PULT and CPM? Any one of you can tell me what is the difference between PULT and CPM? I am audible to you.
Yes, sir.
That means you can hear to me what I'm asking you. I'm asking you, any one of you is aware of what is the difference between PULT and CPM? No. Okay. Now see to the difference. What is the full form of PERT? That is program or project evaluation and review technique. And CPM is critical path method. Now what does that mean? PERT is a technique used to manage the uncertain task of a project, whereas CPM is a statistical technique used to manage the activities of a project. Method is to control time, and in CPM, its method is to control cost and time. As far as progress is concerned, it is this part is used in research and development projects, whereas your CPM is used in construction project. As far as to manage it is concerned, it is unpredictable activities. But in CPM, the activities are predictable. It is now the thing is that where they can be applied. PERT is basically applied in research and development projects, whereas your CPM, it is a non, it can be applied for non-research project, for example, shipbuilding, civil construction, etc. Are you aware of how the CPM chart is prepared?
CPM uses
You're
to
not aware
find
of?
critical. CPM is done by
I,
finding critical path, which is the path that takes longest time.
ah, okay, okay. That means it will be good that if I straight away go to a problem. Yeah, okay, fine. Now see, these are the activities of a green construction company project. You can see that there are different activities from A to N. And you can see the word. It is written immediate procedure. And what is the expected estimated duration? Time. This is almost similar to the same problem what we did some time back, as far as the terminology is concerned. Now the thing is that when this thing is given, see to it, these are the activities, and these are the same activities which will be performed when this particular activity will be completed. And for completion of that activity, this time is given to you. So what I will be doing, I will be drawing, connecting first of all these activities with this. First step will be everything is given to us over here, which is the follower and which will be drawn first. Now, this is the diagram which starts. These are the activities which were written over there, and from that, this has been drawn. These are the activities A, B, C, D, E, F till N were the activities, and these are the numbers written. The numbers written on them is the time which they are going to take. This path has been followed. This path has been drawn from that data. Now we have to find which is the best suitable method for completing this project. The best, shortest route by which this project can be completed. All the activities had been planned A network diagram has been formed. We can use Excel spreadsheet and we can draw the Gantt chart from it. These are the different by which the computer's help is taken. Now, what I will be doing, going back to the problem, there you can see that I show you what I how this calculation came. Just have a look at it. From here it started. How it can travel? This can travel in this way. Finish it off. This can travel in this way and finish it off. Start here, move this way, and move, finish it off. Now the last part is one, this, this, and this. Okay, the four paths are there. What are those four paths? How many five? How many paths are there? Six paths are there. Reversing and changing is all possible. So I started from A, B, C, D, G, H, and M, respective time or the length in weeks is calculated. It comes out to be 40. Second one, second path is A, B, C, E, H, M, and finish. That takes 31 weeks. A, B, C, E, F, J, K, N. It takes 43 weeks. A, B, C, E, F, J, L, N. 44 weeks. Now, different time has been calculated. The estimated project duration equals the length of the longest path through the project network. This longest path is called the critical path. But how much is the longest? 44 weeks. If more than one path tie for the longest path, they all are critical paths. If in this calculation you might have got 44 two times, so both of those will be the critical path. And your starts from A, B, C, E, F, J, L, N and finish. And the total time is 44 weeks. This is what we have drawn. The paths are being calculated this way. This six paths. Total time is 44 weeks. Maximum time is 44 weeks. That is the critical path. Now we have to calculate for all the earliest start time and the earliest finish time. These values will be taken from the given value what is given to your problem. Now you can see I'm just telling you earliest start time because this was the starting, so it will start from zero. Earliest finish before 2 weeks it cannot be finished. So that means here it will be two. Now earlier start will be two and earliest finish will be 2 plus 4 6. Similarly, it will be 6 plus 10 16 over here and earliest finish will be 6. And when we move over here, so here the system is 16. So 16 ES and EF will be adding this 2 to it 22. Now 16 over here plus 4 20. 16 plus 7 23. They are all calculated for all values they have to be calculated. And we have to see the path. Now this is the path. we have to check it for the path what we have selected, the critical path. In the last we can see over here it is 44 and here it is 44. The maximum part is coming out to be 44. That means your finish time will be 44. You have calculated in CPM method 44. The finish time is 44 if everything stays on schedule according to the start and finish time of each activity. The earlier start time and earliest finish time values of all the activities of green, these are the CPM showed 44 weeks. This calculation shows 44 weeks. Moving this way, it is by the backward path. There are different notations of representing it. In the center value, in the here you can see this is the activity, this is the estimated duration, and these two numbers are written as start comma start bracket 38 comma 42. The first number is earlier start time and the for second number is latest finish time. And when we are moving from backward side, so this will be the earliest finish time and this will be the latest finish time. Okay, now any question from anyone? Do you have any question or I should conclude the session?
No question from my side.
Okay, anyone else?
No question from me, sir.
So can I conclude the session?
Yes, sir.
Okay, all the best for
Thank
your
you, sir.
exam and for your future.
Thank you.
Thank you. Wish you the same, sir.
Thank you, sir.
And a happy Christmas to all.